The Orion Cluster, or the Orion Nebula Cluster, ONC, represents one of the most fascinating and studied objects in the night sky. Nestled within the Orion Nebula, which itself is a part of the larger Orion Molecular Cloud Complex, the cluster is a vivid laboratory for the study of young stars and their development. This cluster is relatively close to Earth, situated approximately 1,300 light-years away, in the constellation of Orion, making it an accessible and invaluable resource for astronomers. This cluster is not only young but extremely active, estimated to contain over 1,000 young stars formed within the last few million years. These stars vary widely in mass, from less than 1/10 to many times the mass of the Sun, encompassing a wide array of stellar evolution stages. The most famous among these stars are located at the center of the cluster, known collectively as the trapezium due to their arrangement in a trapezoid shape. These massive stars are significant because their intense ultraviolet radiation is primarily responsible for illuminating the surrounding nebula, giving the Orion Nebula its characteristic glow. The Orion Nebula, the home of the Orion Cluster, is one of the brightest nebulae in the sky and is visible to the naked eye under good conditions. It serves as an excellent example of an H2 region, a type of emission nebula created by ionizing radiation from young, hot stars. The radiation strips electrons from surrounding hydrogen atoms, which then emit light as the electrons recombine with the hydrogen nuclei. This process gives the nebula its stunning array of colors, predominantly the reds and pinks that are typical of H2 regions. In addition to the large stars, the ONC also contains a wealth of protostars, which are stars in the earliest stages of formation. These protostars are surrounded by circumstellar disks from which they continue to accrue material. The Orion Cluster provides a critical snapshot of early stellar life, from collapsing gas clouds to fully formed star systems, offering clues about the disk accretion processes and the initial conditions that lead to the formation of planetary systems. Furthermore, the Orion Cluster is surrounded by dense molecular clouds rich in gas and dust. These clouds not only feed the formation of new stars but also contain the building blocks for planetary systems. Within these clouds, complex organic molecules necessary for life have been detected, suggesting that the processes leading to habitable planets may be common in the universe. The dynamic environment of the ONC is also marked by dramatic phenomena such as stellar winds and outflows, particularly from the more massive stars. These winds can reach speeds of several hundred kilometers per second, exerting tremendous influence on the surrounding nebula. They help to clear out areas of dust and gas, potentially aiding in the visibility of underlying stellar populations and influencing the formation of new stars by compressing nearby material. Studies of the Orion Cluster have been enhanced by modern telescopes and instruments that can observe in various wavelengths, from radio to X-ray. These observations reveal different aspects of the cluster, such as the high-energy environments near massive stars or the cold, dense cores of protostellar clouds. Each wavelength provides unique insights that help astronomers piece together a comprehensive picture of star formation. The exploration of the Orion Cluster continues to yield vital information about the universe's stellar and planetary genesis. By studying this microcosm of cosmic activity, scientists hope to understand not just the life cycle of stars, but also the broader mechanisms governing galaxies, including our own Milky Way. This cluster, with its rich tapestry of astronomical phenomena, remains a cornerstone of astrophysical research and a constant source of awe and wonder.